Hey, what's up, everybody? So it's Greg here from Greg's Tutoring at NYC. We're going over the 2022-2023 Student Handbook for the SHSAT. We did all the Form A math, all the Form B math. We did all the grid-ins, and now we have left the grade 9 mathematics sample questions. So we're just going to jump right into that. I'm probably going to split this up into a few pieces. Um, they don't give a lot of space here, as you can see. So I'm going to do the questions, I think, uh, use the least amount of space and then come back to some of the others, either in the same video or split them out. There is a few algebra ones that have at least two solutions, and it's worth exploring them. So I might even spin questions off by themselves. There's only 13 SHSAT 9 questions, but and I may actually split this up into about 4 parts. All right, let's just get into this. So the first thing they give us is that 0.44 is equal to x over 25. As far as I'm concerned, 0.44 is 44 over 100, right? This is times 4. 24 times 4 gives the 100. So we're basically going to go the reverse way and do 44 divided by 4 and get 11. And we're just done with that question. X is equal to 11. There's really nothing else here to be done. Formally, we have 0.44 over 1 is equal to x over 25. And if we do the cross product, we get x is equal to 25 times 0.44. And again, that's just as easy if you did it this way. I wouldn't even bother with that. This is so obvious. And it's basically a giveaway question. Number 2 and 3 can have more evolved answers. So that's two of the questions that I was talking about. I might spin off by themselves. If nothing, at least come back at the very end. Okay, number 4 says, which number has a value that is located between 7 and 8 on a number line? So if it's between, it does not include them. So it's 7 point something all the way. It's actually 7 point something because it's all values of 7 right up until 8. So it could be 7.999999999 or 7.001. And of course, it can be fractions. So it could be 7 1/4, 7 3/4, 7 and 1 millionth, all these kind of things like that. So my students normally hit a mental block when they see stuff like this. This is the square root of something, and they just left with, I don't know the formula to do that. I don't know the algorithm to do that. But if you kind of step back from this, they're not asking you to do much here. 6 squared is 36. And the next highest up is 7 squared. So that's equal to 49. All right? So that means the square root of 37 has to be 6 point something. Or 6 and, right? This has to be 6 point something. Or 6 and somethings as a fraction, right? There's no alternative. So we can do the same thing here. 7 times 7 is the 49, and then 6 times 6 is the same thing. So we get the same thing. This is between 6 and 7, right? 36 to 49. 49 here, this is 7, so 7 squared is equal to 49, and 8 squared is equal to 64. So the answer has to be G. The answer to this has to be 7 point something, or 7 and some fraction, right? So that's between 7 and 8 on a number line, right? And then just to double check to be sure, 8 times 8 is 64, and then 9 times 9 is 81, right? So this H is between 8 and 9. So the only one that works for 4 here is that. And again, just like question number 1, this is almost something you could do in your head. I generally suggest to write down as much as possible, but that's the deal. Let's just go straight over to number 6. Which of these numbers is irrational? Right? So this is versus rational. I'll just put rat. All right. So let's just look at f. F, the square root of 9 is equal to 3, and also technically minus 3. All right. 9 over 7, that's two integers, and then the square root of 7. And then we have 0.7 bar. You should all know that this is 7/9. And you should all know how to convert repeating decimals into fractions. But this one's an obvious that 7 bar is 7/9. So this is rational. These two are rational. That's rational. And this is the one that ends up giving us so wacky stuff. I believe the handbook in the description of question number 6, it actually produces this out. But if we use the logic we used over here, right, the answer to this, right, if we have 2 squared, that's 4. If we have 3 squared, that's 9. So the answer here is between 4 and 9. That's a little different than the others. All right. So it's probably 2.5 or something. I'm just making a wild guess. Because 25 squared is 625. So we're getting closer to there. So it's probably 2.6 or 2.7. And then there's a whole bunch of other digits. If you actually try to compute the square root, it goes on into infinity, I believe, if I remember this answer. So H would be the one that's irrational. It just keeps going on forever. And again, I don't like solutions where process of elimination E goes out, process of elimination F goes out, process of elimination G goes out. I don't like when we're just left with the choice that we kind of can't prove. But this one again, it's too obvious. It's too obvious. All right, so let's go backwards into question number 5, which is geometry. And they have an illustration. They give us T, that is angle T, that's not point T. They give us two lines, K and M. K and M is here. They look parallel, and they give us angle J, that is not point J. They give us a line P that intersects L and M. All right, so if it intersects, then there's a whole bunch of rules that kick in that allow us to do certain things and make identities. So they're either going to give us T and ask for J, or they're going to give us something else. But somehow they're involving T and J here. So this is a traditional setup where we have two parallel lines with another line intersecting it. All right, so let's go through the words. In the figure above, K is parallel to M. That's what that means in math. You should know that. If you don't, you need to go review what parallel and perpendicular and stuff like that are about. Okay, anyway, this confirms what I thought just by observation. But remember, we cannot just go strictly by observation because things are not to scale. And those are not parallel unless it tells us they are, or it's showing a graph, a coordinate graph, okay? Because coordinate graphs and number lines are basically the only things that we are guaranteed are drawn to scale unless the question tells us that. So, all right? So that's why it's important to cross all these T's and dot all these I's. Straight line P intersects both K and line M. The measure of T is 47. So 47 is here. Okay. What is the measure of J? All right. So there's a couple ways to solve this. There's a whole bunch of identities here. Since J is that angle, it turns out that this angle right here, I'm going to call it J prime, is also the same angle. So basically all we have to do is 180, because this whole thing here is 180. Subtract from that the 47, right? When we do that, we get 133. Always add these back up. 133 plus 47, we get 170, 180. A lot of you, when you do these angle computations, you're normally off by 5 or off by 10. And the reason you're normally off by 5 or 10 is because your brain tells you that's the answer, and you do it in your head. Don't do it in your head. Write it down and do the reverse operation to ensure that you're giving a fault tolerant mechanism here to make sure your answer is correct. It's one thing to know how to process this kind of question and then just do a careless error and be off by 5 or 10. I can tell you I've reviewed thousands of questions like this now, both asking students what they did and also watching them do it live. And 50% of the time, easy, students are going to say this number off by 5 degrees or 10 degrees. Why off by 5 or 10? Because most of the angles work that way. All right. Normally you're going to have like 180 minus 45, and some of you mess that up, or 90 minus 45. And some of you say that's 55 or something like that. It's not 55, it's 45. 90 minus 45 is 45. All right. So that's the kind of thing you need to do here. So anyway, J prime is 133, and therefore J is 133. All right, so we can do that. We could have also viewed this a different way. And let me change the color here. Let's use blue just to confirm it. So if T is 47, let me try to blow this up now, that this angle right here in this blue, that's also 47. Okay, and then that means this angle plus that angle is also 180. So again, we would still end up doing the 180 minus the 47. All right. We can also have computed, let me change the color just to be clear. Let's use black. This angle here also turns out to be 133. And if nothing else, we know that's a vertical angle to here. But we can work the same way. All right, so if that's 133, that means this is 133, which means J, which is the vertical angle to that, is also 133. Or what we could have done was, because this is 47. Let me change the color another time. Let's use the green. If this is 47, then this angle here is also 47, which, by the way, means that's 47 as well. So we can compute J through many different ways here. Okay. Yeah, we can even know that this and this add up to 180. Because again, when we get rules, we're having lines like that, right? There's certain rules that kick into place. Involving these shapes and these interrelationship between the parallel lines. And this only works because they're parallel. All right, so that's our deal there. So that was that question. We're going to skip 2 and 3 for now. So what do you do? 1, 2, 3, 4, 5, 6. Okay, let's try 7. 7 I might leave for by itself. 8 is also busy, so I'm going to skip that for right now. 9 is also busy. I'm going to skip that. 10 piggybacks off of what happened with 9. 11 technically is more advanced. But I'm going to do that one right now just so we can fill this video up a little bit and make the next one more balanced. All right, so there's 2 ways to solve this. One way is really fast. And let's just review it. So it says, how many solutions are there to the equation? The absolute value of something is equal to -2. So by definition, the absolute value always returns a positive number, right? Or 0, right? Absolute value. So there's no solution. It's just that simple. There's no solution to this. The absolute value of something cannot yield a -2. It just doesn't happen. It doesn't work. All right. So there's a big hey here. Yo. So this deals with your mastery of the math, your attention to detail, your acknowledgement of the numeracy involved here, and just making sure you know what you're reading. But I'm going to go through the process of this anyway to solve this algebraically, just because some of you don't know how to do that or are not keen on it. So what we need to do is write 4x plus 6 is equal to the minus 2. So what I'm basically doing is writing it the same exact way it appeared without the absolute value signs, okay? And then we're going to solve a second version of it, which is 4x plus 6 equals, in this is minus 2, so what I'm going to do is the minus version of that of minus 2, all right? I'm going to change the color for 2 seconds because there's actually another way to do this, and you may have been taught that way. It'll still yield the same thing. So one way is to basically take the positive version of this, okay, and then do another one with the minus version of that, okay? So actually, let me write that one out better. So we would get minus 4x plus 6, and then we leave the other side alone. So that would be, the fuchsia would be your two things. In fact, let me write this one out here. It would just be 4x plus 6 is equal to minus 2. All right, so this is an alternate way to the way I'm doing it, where one side is left alone and then you do it again negated. So I often like to flip the sign of the constant, but both ways will work fine. So let me go back to the green, because that's my preferred way of doing it. But the fuchsia ways work as well. You're still going to get an x equals something on both sides. So anyway, we have 4x plus 6 is equal to minus 2. So we're working on the green only. I'm going to take 6 away from both sides, right? And we get 4x is equal to minus 8. Divide 4 on both sides. And we get x is equal to minus 2. All right? So that appears to be a solution. And on the right-hand side, we have 4x plus 6 equals minus 2. So that's just becomes 2, right? So we're going to subtract 6 from both sides again. And we get 4x, this cancels out, equals minus 4. And we divide both sides by 4. And we get x is equal to minus 1. So technically this appears that we got two solutions. But even if we plug those in, right, we would have the absolute value of 4 times minus 2 plus 6, the absolute value of that. So we have minus 8 plus 6, right? And then we get the absolute value of minus 2. Well, that's equal to 2. And 2 can't be equal to minus 2. We have the same problem with the minus 1 if we do the absolute value of 4 times minus 1 plus 6. Close that, we get minus 4 plus 6. And we also get the absolute value of 2, and that's 2. But 2 is not equal to minus 2 again. So we have a violation. And by the way, this is one of the rules you should be doing anyway, even though this one was pretty obvious because it said the absolute value of something was minus 2. That's what makes this a 5-second question. On some of the other ones, it's harder. And you should always feed your answers back in. So here would be your scenario where you did all this work and neither, quote, solution works, because neither is a solution. It's an invalid, this is mathematical gibberish, the original question. All right, let me change the color one more time. This expression, I'm circling in a blue, it's mathematical gibberish. It doesn't make any sense. All right? So there's no solution to this. And even if you went through the steps, feed your answer back in. Don't just say, oh, I got x equals minus 2 and x equals minus 1, and therefore the answer is C, 2 solutions. No way. It's not it, okay? So that's number 11. 12 is not too bad. So just looking at it, we have a scatter plot. This is a whole bunch of kind of random dots in a coordinate grid. We have the x-axis, we have the y-axis. Things are by 1, 2, 3, 4, 5. Same for the y-axis, 1, 2, 3, 4, 5, and minus. But I observed this clumps of stuff here. There's a whole bunch of stuff uh, constrained by the 4 and the 6 here, and the 4 and the 5 there, and over here between the 0 and the 1, and the 0 and the 2 on the y. All right, so we kind of have isolated patches of information. All right, so there's not anything to be there except it just seems to be packed and clustered together. So the scatter plot shows data that a researcher collected. Okay, so we almost should gut feel like there's not really a scatter here because there's just two distinct groups of data. All right, so let's see what they're going to try to ask us about this. Which statement correctly describes the data? The data has a positive linear association. It doesn't really, because even though if we were to consolidate the data, we kind of get a line like that. There's something not computing here. We basically have two distinct groups. So E doesn't really work here. So E's out the window. F, the data has a negative linear association. Well, if it's anything, it's positive. So it's not F, it's not negative either. The data have clustering. Absolutely, unequivocally so. So that would be the answer. And then just to go through H, the data have outliers. We can't argue that this group here, this cluster here, and this cluster here, it's kind of hard to argue that the two groups are outliers. I guess they are to each other, but the real deal is if we have groups of outliers that are consolidated, each group is consolidated, that's exactly what a cluster is. All right, so yeah, that's that. And then 13, we have what is a right angle, and it not appears to be a right angle. That tells us right there it's a right angle. I see this is 8 and this is 8, and I know automatically that this is 8 the square root of 2. Okay, I know that automatically because I know my Pythagorean triples, and you have basically 1, 1, the square root of 2, or if you will, x, x, x the square root of 2. All right, and that's true for an isosceles triangle because this is 45 and that's 45. So you guys should know these kind of things like that. If not, you run the Pythagorean theorem. Okay, but let's see what the question is. I'm just talking out loud here, and I don't even need to write this at this point because this just leaps out at me. It's instantly when I run this kind of question. So what is the length of x? So I already said the length of x. All right, so this is easy peasy. The answer's there already. Yay, hooray. Wait a second, it's not there. What happened? All right, so you're going to find that the form of answers you come up with are not always the form of the answers of the choices. All right, so we need to do a conversion. So if I have 8 the square root of 2, and all these are the square root of something. All right, so what I want to get this down to is, I don't know if many of you know this, and if you don't, you should. The square root of A times the square root of B is the same as the square root of A times B inside of the whole square rooty thing. All right, so that's an identity. The square root of A by itself times the square root of B by itself is equal to A times B, the square root of that whole AB. All right, so that's what we're trying to shoot for. So what we want to do then is do something with that 8 that will allow us to drag it into the square root of the 2 part. All right, so let's go purple. We haven't done that in a while. So 8 is the same as the square root of 64, right? And then the square root of 2 is just the square root of 2. And if we follow the rule here, then this is the square root of 64 times 2. And if we simplify the inside of that, we get the square root of 128. Okay? And by the way, this is inches, that's inches, and all the answers are in inches. So we do not need to do a unit conversion. And the answer here would be C. All right? That's what they're asking us to do. There is a second way to solve this, which is if you didn't know some of what I wrote here. So let's say you didn't know about this Pythagorean triple, but you do know that this is a right angle. All right? So in that case, we're trying to solve x, which is the hypotenuse, right? So basically x squared is equal to a squared plus b squared. Okay, in this case, we know that a is 8. So we have 8 squared plus, and b is 8 again, 8 squared. So we get 64 plus 64, and then that's equal to 128. Well, what is equal to 128? It's x squared. All right? So if we take the square root of both sides, so the square root of x squared, and then the square root of 128. Okay, well, the square root of x squared is just x. And we can leave that alone because that's what we're shooting for. The square root of 128. Okay? Be careful with these because we are told to simplify all answers, and yet we're not asked. The choice 8 times the square root of 2 is not one of the choices, right? So in other words, the simplification of this is 8 times the square root of 2, of simplifying that radical, and yet it's not asking us to do that. All right. All right. So that's the last question. I'm going to split this into 2 videos at least, and come back to the others. Please like, please subscribe. Hit me up an email, GregsTutoringNYC @gmail.com. Peace, y'all.